one.
Hello everyone, hope you all are doing good. Okay, this is Ashishwini Chigurupati and I'll be the moderator for today's session. So firstly, let me welcome you all to the webinar Application of Biostatistics and Research organized by Squad Medical Research and Global Association of Indian Medical Students and International Foundation of People Welfare and Development IFPWT. We have with us Mrs. Sapna J. Madas as our speaker for the session today. Mrs. Sapna Madas is the Director, Head of the Data Management and Statistics Department at the Palmacare Research and Education Foundation. She has completed her Master's in Statistics from Pune University. She has been a certified data scientist with an experience of over 15 years in the field of healthcare research. Her expertise has been performing statistical data analysis using basic as well as advanced statistical techniques. With her great work experience, Ms. Sapna is involved in every research project at the organization, right from the initiation of the study, that is study design, up to the completion of the research project, that is analysis and publication. Prior to inception of Pure Foundation, Sapna has been proudly a part of the Just Research Foundation, CRF, for 14 years as the head of data management and statistics department. During her tenure at CRF, she has completed more than 200 epidemiological, academic, molecular, air pollution, and clinical trial studies. The research findings of which has also been presented at National Conference of Indian Chest Society and National College of Chest Physicians, NAPCON, as well as International American Thoracic Society, ATS, European Respiratory Society, ERS, and International Primary Care Respiratory Group, IPCRG conferences. She in person has also been presenting her work at ERS, International Conference, under the title of Young Scientist Award, and also received a Silver Sponsorship Award, ERS, in the years 2012 and 2016 respectively. She has been instrumental in the development of the two-day statistical techniques and research methodology workshops, which has trained medical professionals, researchers in medical healthcare, public health, pharmaceutical industries, and PG students from life sciences all across India. She has supported several MD and PhDs in their thesis and dissertations, and also several interns from the University of Pune, Department of Statistics, in their post-graduation projects. Welcome, ma'am. We are honored to have you as our speaker today. Over to you, ma'am.
Yeah, thank you, Yashaswini. Thanks for the brief introduction. So today I'm going to talk about some of the important application of the statistics, and as a researcher, why it is important that you should have some basic knowledge about the statistics. So knowledge about the statistics will not only help you to design or conduct your research better, but will also help to present and disseminate your result of the finding in more systematic way. So as a researcher or the clinician, when you have a lots of or a huge amount of data of the patient on a different diseases, does this data really make any sense to you? So unless and until you summarize all this information in a very systematic way and make an important or the inferences out of this data really don't have any sense, or it don't have any importance or the use, I can say. So, but however, when we consider as a statistician this data pool, we will help to collect this data systematically, organize this data systematically, analyze the data using an appropriate statistical method, and finally interpret and present the result. Now, these findings or the result will help you to disseminate your knowledge to the target population. We really help you make the meaning of your data. How? By generating the information and extracting the knowledge from your data. So this is what the statistics is all about. So let me go through an example. Now everyone knows about the census of India. Now the census is one of the biggest population survey where each and every individual is participated. What is it all about? Census is nothing but a systematic way of collecting the information of each individual, wherein you collect the information about the different attributes. For example, the age, gender, or the education detail. So there is a huge amount or the massive amount of data is collected almost all the parts of the country. And the data is mainly collected into the paper format. Now, the first step is that if you want to really extract some meaningful information from this data, the first step is that you have to organize this data properly. So first is you need to transfer all the data from the paper format to the electronic format. And there is a how to capture the data or the store the data into the electric format. There is a systematic way because the data feeding is used to analyze your data. So there is a specific way in that manner only you have to feed the data. So once you feed the data into the database, then using the various statistical technique, then you analyze this data. Now from the recent census, they have got some information or the result you can say. So what are all these information? So the sex ratio is 943, literacy rate is 74%, and the density of population is 382. So all these results are into the number format. So to convey all the result into the common man's language, you can interpret this as a India is a densely populated city with a very low sex ratio and the literacy ratio is also not too high. Now you can improvise or even better with your analysis if you compare this result with to the previous census data. Now when we compare the 2011 census data with the 2001 census data, then you can see that the sex ratio has improved from 933 to 943. So the literacy rate has taken a shoot from 65% to 74%. But it only inspires us to that we can even do a better in terms of the when you talk about the education. So the density of the population is increases, which means that the place for an individual is gradually decreases. But when you talk about the statistics, so most of the times the results are presented in the tabular or in the number format, which is not easy to understand for everyone or the common man. But you can use this data into the various graphical format to simplify your result. So what is statistics? So statistics is nothing but a science which deals with the method of collection, organization, analysis, interpretation, and finally the presentation of your data. And the biostatistics is one of the special branch of the statistics which applies to the biological sciences, health, and the medicine. So when you talk about the research always starts with asking a good research question, and all your research is centered towards the finding an answer to this particular research question. So when you conduct any research study, there is a so why you conduct a research? So you always want to put a light on some hidden things or the mysteries. You may want to extend your knowledge in particular field or maybe the area of your interest, or there may be the some known facts which you want to test in your population. So research always start with a good research question on all research centered toward finding the answer for that particular question. So research is nothing but a systematic and organized way of finding an answer to your question. Now, when you conduct a research, there are the various steps involved in research. So first, you have to identify the research problem. So once you find out what is the your research question or what is the problem, then the first thing you have to do is you have to do a review of literature. So why you conduct a review of literature? Because you want to check that whether the similar kind of the research is already done, and if it is done, then what are their findings? Then based on all this information, you formulate your research question. If if you are going to conduct a research which will give you the similar result, then there is no use that conducting the research again. So your research question should be innovative. So you will be able to extract some important and the new knowledge out of that research. Then only we can say that the research is really helpful to the mankind. So once you formulate your research question, now the next step is to finalize your the study design and finalize the population or the sample size. How many subjects you will need to conduct that particular research. So once you finalize your the study design, sample size, research question, then the main part is execution of your research, where you collect the all important information which will need or require to answer your research question. After collecting all the necessary information, the next step is you have to process your data or you have to analyze your data using the different kinds of the statistical tests. And at the end, you have to report the result. So when you complete all this process, so ultimately you will find out the answer for your the research question. So what is the role of statistics in research? So whenever you conduct any research study, so the statistics can important from your the planning phase till the publication. And in every phases, the statistics is having the different roles and the responsibility. So when you talk about the project planning or when you write your the protocol, uh, in that case, as a statistician, they has to perform the sample size calculation. This is nothing but the number of subjects required to conduct your research. The second is the statistical analysis plan writing. So when you formulate your research question, so based on that, you have to write your research hypothesis. And to test this hypothesis, which statistical method you are going to use, this is you have to mention into the statistical analysis plan, and this is also the one of the part of your protocol writing. And the third is the questionnaire designing and the coding. So the when you design the questionnaire, so there are a lot of information you are collecting. So it is always suggested that you have to code your responses. This is mainly because from the data entry point of view, because it saves a lot of time while doing a data entry. Now, in the second phase, when you actually execute your the research project or collecting your data, so the important thing is that whatever the data you will collect, it has to be transferred electronically. So that is nothing but the data management. So the statistician has important role in preparing the database. Again, they help you to clean and validate your database. So why it is important? Because all your statistical analysis is based only on this data. And if there are error in this data, then ultimately it will affect your result or mislead your result. And in the third step, that is the project reporting. So all your reporting is based on the statistical analysis output. And finally, they also help you in preparing the reports also and in the publication. So one of the first important role of the statistician in the planning phase is to calculate the sample size. So it is one of the tedious job or the tedious calculation you can say when you conduct a research study. So where to begin? So even if you want to conduct a small, the survey kind of study or any drug type, you have to find out the minimum number of the subjects required for conducting that study. So where to begin? So whether your sample size calculation is based on how much budget you are having or what is your timeline, whether you want to complete that study in the 3 months, 6 months or 1 year. So in real life situation, these two are very important thing you should consider. But this is not the base or the foundation to calculate the sample size. So you have to select an appropriate and optimum sample size. So these two words, the appropriate and optimum, are very important. When I say appropriate, what is it mean by? When you conduct a research study, it always based on the sample population because it is not feasible to conduct a research study based on the entire population. Census is the only survey wherein you consider each and every individual. Otherwise, your research is only based on the sample. Therefore, your sample should be representative of the population. Then only whatever the finding will come out of research, you can generalize to the entire population. And the second is your sample size should be optimum. It means that you should not select a very less number of sample size versus the very huge or the large number of the sample size. If you select a very small sample size, maybe you will not get a result, and there may be chances that you have to repeat the experiment or your research again. The opposite side, if you select a huge number of the sample size, okay, as your sample will increases, you will go towards a population. It means that the accuracy of your research is better and better. But it is not wise, because if the sample size is large, then you need a lot of money, the manpower, and the timeline also. So it is not feasible. And if you are conducting a drug trial or the intervention trial and you are unnecessarily selecting a large number of the sample, it means that you are exposing a lot more people to a drugs or the treatment, which is ethically not correct. Therefore, your optimum sample size is required for the following reason. It allows you to conduct an appropriate analysis to provide the desired level of accuracy and to allow the validity to the significant test. Then how to calculate the right sample size? Sample size calculation is nothing but a mathematical procedure to calculate the number of subjects to be included in your research study. Now there are the various formulas available, ready-made statistical table for a particular research question, and different software like the Inquiry Advisor, NMaster, and the SAR, using which you can calculate your sample size for the research studies. You can use any of this method to calculate the sample size, but this calculation is based on the planned method of statistical analysis. So what is mean by this? So once you finalize the research question, then based on your research question, you have to formulate the research hypothesis. And to test this hypothesis, which statistical test you will be going to use. This is nothing but the planned method of analysis. And this method will be used to calculate your sample size. When you calculate the sample size, there are a lot of information you have to consider. There are some of the very important determinants you should consider when you calculate the sample size. The sample size calculation is mostly based on the primary outcome of the study. In many cases, there are maybe more than one primary outcome or the secondary outcome, which is very important from your research question. If these are the cases, then you have to calculate the sample size for each of the important outcome of your study separately, and whichever is the maximum, then you have to consider that as your final sample size. Apart from this, you should consider that what type of the study design you are thinking, whether it's an observational study, again in the observational, whether it's a cross-sectional study, cohort study, or the case control study. What is your objective? Whether you want to find out the risk factor or prevalence of any particular diseases. When you talk about the interventional studies or the randomized control trial, whether it is a RCT or the non-RCT, again, what is your objective? Whether you want to find out the difference between the two means or the proportion. Second is, what is your level of measurement? This is nothing but what type of the data you are collecting, whether it is a continuous data or the categorical data or the time to event data. Time to event data, it generally the time to response to the treatment, or mainly it is useful in the cancer trials or something like that, time to death. And the third is that how many number of groups you are going to consider. That is, it is single group, two groups, or more than two groups. So once you collect all this information, there are the two classical approaches to calculating the sample sizes. So one is the precision analysis. So when the objective of your study is that you want to find out the prevalence of any particular diseases, or you want to find out the accuracy of a diagnostic test, in that case, you have to use the precision analysis as one of the approach to calculating the sample size. And the second approach is the power analysis. When you want to compare between the two groups or the intervention kind of the studies, That time you have to use the power analysis as the approach to calculate your sample size. Now consider the example of the sample size estimation using the power analysis. Suppose the randomized trial was conducted by a nutrition department to see whether a dietary supplement given to a pregnant woman will reduce the systolic blood pressure during the time of the delivery. Now, this is the research question. So, in this trial, they want to test that whether the new dietary supplement is effective in reducing the blood pressure. So, one group will receive the new supplement, whereas the other group will receive a normal diet. Now, based on this research question or the information, you need to extract the information about the what is the study design, what kind of the measurements they are going to use in this study, and how many groups they are studying. Now here, the objective of this study is to the comparison between the two groups. Study design, so this is just basically the simple study design, just want to compare the systolic blood pressure between the two groups. Systolic blood pressure, these are the numerical value, so your level of measurement or the data type is the continuous. And number of group, so one group receives the normal diet versus the one group receives the dietary supplement. So the two group will be involved in this particular study. So once you get the information about what is the study design or the number of groups, then there is also some clinical information which you have to provide to the statistician for calculating the sample size. So what the clinical information you have to provide? So this is nothing but the MCID. It is a minimal clinically important difference, and the second is the estimate of variability. When you want to see the effect of a particular treatment, then you have to provide that how much difference you are expecting from the standard treatment to show that the new intervention is more effective. Now, how to get this information or from where you will get all this information? Obviously, you have to do a literature review for this, or from the previously published studies, you will get all this information. If not, then you need to conduct a pilot study and you have to get this data. For this particular research question, they have conducted a pilot study, and according to the pilot study, the standard deviation of systolic blood pressure was 40 mmHg, and the expected clinically important difference between the two groups is 20 mmHg. Now, this is all about the clinical information. Along with the clinical information, you have to provide the statistical information also. So what all statistical information you have to provide? So these are nothing but the type 1 error and the power. So what is mean by these are the type 1 error and the type 2 error? These are the statistical terminology and which are very difficult to understand. So let me take you through one example and to explain you what is mean by these of the error. So when you conduct a study, it is based on the sample population. You are not considering the total population. Therefore, there is always chances that some kind of the error is there. So you have to consider this error while calculating the sample size also. So consider an example of the courtroom. So in the courtroom, whenever a case is presented, the defendant is always considered as innocent until he or she proven to be guilty. Now, based on this situation, if you formulate your research question, then you want to prove that the defendant is guilty. This is nothing but your research hypothesis. But for this, you have to provide it all the evidences which can prove that whether he is guilty or not. So until that, the defendant is considered as a not guilty. So that is your null hypothesis. Now the prosecutor need to present all the evidences, and then based on the evidences, the jury has to decide whether the person is guilty or not guilty. Now, in this case, there are the four possibilities. The two possibilities of the correct decision and the two possibilities of the incorrect decision you can see. So what are these possibilities? So the first thing is that, so in reality, maybe the defendant is not guilty, and based on the evidences, the jury has decided that the person is not guilty. So this is one of the correct decision. And the second is that in reality, the defendant is guilty, and the evidences also support that the person is guilty. So this is also one of the case of the correct decision. Now again, there are the two probabilities of the incorrect decision. The first probability that, so maybe the person is not guilty, but based on the evidences, the jury has said that the person is guilty. So here the problem is that, so an innocent person get into the jail. So this is one of the serious kind of the error you can see, because if the person goes to the jail, then it is, lifetime there is a tag that the person is having the criminal record, and which is not good. This is very serious thing. So this is nothing but the type 1 error. This is your the probability of rejecting the null hypothesis when it is a true. We always want that this error should be the minimum as 5% or something. And there is one more probability of the making the incorrect decision, and that is maybe in reality the defendant is guilty, but there is no sufficient evidences, and therefore the guilty person get out of the jail. This is nothing but your the type 2 error. That is your probability of accepting your the null hypothesis when it is a false. So these are nothing but your the type 1 and the type 2 error. So while calculating the sample size, you have to provide these two errors. So how much error you are expecting or allowing in your research. So type 1 error, so most commonly the 5% of error is accepted or the allowed by the most of the researcher. And the second is the power, that is nothing but your the 1 minus type 2 error. And the power of the study is ability to detect the difference if the differences truly exist. It is up to the investigator. 80% is considered as a minimum power, and you can extend to the 90 or 95% also based on the importance of your research. Now, once you get all the clinical information and the statistical information, so you have to just feed all this information into the right formula, and you have to calculate the sample size. When I feed all the information, then I got that n is equal to 63. It means that I need to recruit the 63 subjects in each group to conduct this research study. Now the same output you can get using the statistical software also. So here I have performed the sample size calculation using the nmaster software. Again, if you want to calculate this using the software, you have to enter the correct credential. Then only you will get the correct sample size. So here I have entered the information like my sample size is based on the mean because I want to compare the mean between the two groups. Then I'm having the two groups, and my hypothesis test is that I just want to compare the mean of the two groups. So once I have, you will enter all this information, you will get your the required sample size as a 63 sample in each group. Now, whatever the information you have entered, that is the clinical and the statistical, these are the four important factors of the calculating the sample size. Because the sample size increase or the decrease, it's highly depend on these four important parameters. If your level of significance, that is nothing but your type 1 error is decreases. If you decrease this from 5% to 1%, it means that you want that the error rate should be very low, 1%. Then you have to conduct your study into the huge population. Similarly, if you want the high power from 80% to 90%, as you increase the power, your sample size will increase. The third thing is about the variability. Variability plays a very important role when you talk about the any statistical computation. If your data is the less variable, then the accuracy is high. Therefore, if your the standard deviation is smaller, then you read the smaller sample size to conduct a research. And the last is, if you want to show a small difference between the group, then you have to conduct the study into the larger sample size. So based on this all four parameters, the sample size may change. Now, once you calculate the sample size, it is very important that there should be a systematic way that how to put all this information into your proposal, because you have to provide all the information that if you have calculated the sample size, what is the base from where you have calculated, collected this information, which formula you have used, which software. Again, when you calculate the sample size, you have to consider the dropout rate, because maybe there are some non-responses and you have to throw away the data. So you need to do a provision for the dropout rate also. And there is a specific way that how you have to write about your sample size estimation. So for this particular example, so my sample size of 126 subjects, 63 per group, will be required to detect a difference of 20 mmHg in systolic blood pressure between the two groups, assuming a standard deviation of 40 mmHg with a power of 80% and the two-sided level of significance, that is a 5%. So I have entered all the information whichever I have used to calculate the sample size. And if I consider the dropout rate of 20%, then my this 128% will increase to 158 subjects, and this 63 per group will increase to 79 per group. Then again, I have to provide the references also using which software I have calculated this sample size. Now, this is all about the planning phase or the role of statistics in the planning or writing of the protocol. So there are some of the key points when you calculate or the estimate sample size. The sample size determination is one of the most essential component of every research or the study. Sample size should be estimated early in the design phase of the study. Calculating the appropriate and adequate sample size is rarely as simple as plugging the number into a formula. In case of non-significant finding in a study, calculate the power for the deeper understanding. Now, the next step of the research or the role of the statistician is when you conduct your study and start collecting your data, then the statistician will help to manage your data. Now, the data management is also a huge process. So in most of the time, the data is collected in the format of the source document or in the paper format. Then the first step is that you have to design a database to enter the data. Then once you design a database, so generally it is preferable or said that you have to perform the double data entry to avoid any human mistake. So once the double data entry is completed, then both the database is compared, and if there is any error made by the humans, then all this is corrected and one master or the clinical database is prepared. Once the master database is prepared, then there are the different checks or the data cleaning performed. So this is one of the important steps, because once your data is locked for the analysis, after that you can't make any changes in your data or you can't touch your data. So before locking your database, you have to be very sure that whatever the information feed in your database, it is a correct, accurate, complete. Because if there is a missing data or there is an outlier or some error, then this will affect your analysis or mislead your research. Now, just to explain you, so here is one example of the missing data. Suppose I am having a data of hardly 8 cases, and the data is all about the age and gender. So based on the first table, the average age of a participant is the 30 years. And in the second table, I have taken the same data, only I have deleted the 2 observation or the missing data you can see. And now if I calculate the average age of the person, then it comes as a 26. So just if you are having the 2 missing observation out of the 8, the age is decreasing from 30 years to 26 years. So by deleting the 2 observation, your age is reduced by the 4 years. This is the impact of the missing data. So that's why it is very important that you have to manage your data very correctly. So it should be that complete and accurate. So to resolve all these data queries, it is generally based from your source document. And once all the queries resolved, then you have to lock the database Then after this, you have to perform the statistical analysis. Now to perform the statistical analysis, the data is the main center because all the analysis is based on your data only. Now the data can be used in the different ways to present the research finding of the research study design using the different statistical analysis, modeling, graphs, chart. You can extract a lot of information from your data. So in the statistics, there are the two main branches for analysis. So one is the descriptive statistics or one is the inferential statistics. When we talk about the descriptive statistics, so it helps you to just organize your data, summarize data, and describe and present your data. But you really can't make any inference or conclusion from this data. If you want to make any inferences from your data, in that case, you have to use the inferential statistics. Here comes the role of the hypothesis testing, which will give you some conclusion statement from your research. Then you can apply this research to the population also, and you can formulate some predictive models also using the inferential statistics. But all this analysis is depend on the data, and there are the various types of the data is available. So the first thing is that you should know that what is your data type, because based on your data type, the analysis and the graphics will change. So if you want to perform any analysis, the first thing is that you should know that which type of data you are having. The data is broadly categorized into the two way. One is the qualitative and the second is the quantitative data. The qualitative data is further divided into the two categories. That is, one is nominal and the second is the ordinal. Nominal is very simple. These are just the name category in which you need to calculate the frequencies and percentage. The example of the nominal data is the male, female, yes, no kind of thing. Second is the ordinal. So when you are having a data which is in the rank or the order, then it is set as ordinal data. The example is the severity of any disease. So mild, moderate, severe. And one of the example is the rank of the student. First rank, second rank, third rank. But here the distance between the ranks is not fixed or doesn't matter. Only the order is important. Now, the second data type is the quantitative data type. The quantitative data is again further divided into the two groups. One is the discrete and the second is the continuous. Discrete is nothing but the counted data or the fixed number 1, 2, 3, 4. For example, the number of customer complaints, number of accidents, like that. And the last, the important data you are having, that is the continuous data. So continuous data can take any value between the certain set of the real number, age, height, temperature. Continuous data is very important because if you are having the continuous data, then you can convert the continuous data into the discrete also or the ordinal also. But the reverse way it is not possible. Just to give example, suppose you are, in continuous data you are having the age. So age you can mention as a complete age also 30, 40, or you can use as a fraction also 30 years, 6 months, 7 months, like that. You can divide the age into the different categories, say less than 18 years, 18 to 30 years, and more than 30 years. So you can make the category out of this data. So if you are having the continuous data, you can perform a lot of analysis using this data. Once you have the information about the data, the next is what to describe. So the first is what is the location or the center of your data. This is nothing but the measure of the central tendency. Measure of central tendency is nothing but a one single value which talks about the center or the average of your data. And the second is about the how the data vary, is the variability in your data, or which you can correlate to the accuracy. If there is a less variability, then your results are definitely more accurate. Now there are the three different measures of the central tendency: the mean, median, and mode. So is there any differences between the three measures of the central tendency? So mean, which is nothing but the average, it is the most commonly used measure of location. commonly called as average. If you want to calculate the mean, you have to just add all the observation and divide it by the total number of observation. It gives you the sample mean. The second is the median. Sometimes it is that your data may have the skewed data or having the some outlier present in the data. So even if one or two outlier present in your data, your mean can affect drastically. So whenever you are having or you feel that there is an outlier present in your data, then instead of mean, you have to use the median as a measure of central tendency. And the third measure of central tendency is the mode, the value that occur most frequently in your data. Now there are the three different measures of the central. The measures of central tendency are having some specific characteristics. When you talk about the mean, it consider the all data values, but it is affected by the outlier. So if you are having the outlier, then first thing you have to remove the outlier and again you have to calculate the mean. The second is the mode, which has the maximum frequency, but it doesn't consider the all your data point. It is not affected by the outlier, but there may be chances that your data set may have the multiple modes. The median, it is the centermost value of your data, but again, it doesn't consider the all your data points. Now you are having the three different measures of the central tendency, mean, median, and mode. So which one you have to use? So now this is depending upon the distribution of your data. So the distribution is nothing but the pattern of your data or how your data is follows. So in statistics, it is very common that always talk about the normally distributed data. So what is mean by the normally distributed data? The normal distribution is nothing but the bell-shaped curve. And if your data is normally distributed, then your mean, median, and mode are very close to each other, and there is a hardly very few difference or the small amount of difference is present. But if you have skewed data or if there are an outlier present in your data, then it is suggested that you have to use the median instead of the mean. Mode is generally very rarely used because it is not considered as a very appropriate measure of the central tendency. Now, just one example of how to calculate the measure of central tendency. So I'm having the data of the marks obtained by 20 students in an entrance exam. So based on your data, first you have to check that what distribution your data follow. So I have just drawn a histogram. So here, based on this pattern, you can say that my data is normally distributed. It indicate or it means that if I calculate the different measure of central tendency, the value should be closer to each other. Now, when I calculate the mean, median, and mode, the mean is 75.25, median is 75, and the mode is 75. So all three values are very close to each other. Now, the next measure of descriptive statistics is the measure of the variability. Like the measure of central tendency, there are the different measures of the variability also. So there are the range, interquartile range, the variance and standard deviation, and the coefficient of variation. These are the four different measures of the variability you can see. The range, it is a very simple measure of the variability. You have to take only the difference between the highest and the lowest observation. Interquartile range, when you are having the outlier present in your data, then you have to calculate the interquartile range. So in this way, first you have to divide the data into the four equal parts, and interquartile range is nothing but the range of the middle half score. Now the next is the variance and the standard deviation. Variance and standard deviation, these are the considered as the most important or the appropriate measure of the variability because it is based on all your observation. But when you calculate the variances, variance is nothing but the average of the square differences from its mean. So you have to take the square differences when you calculate the variance. It means if your variable is the age and you are taking the square differences, the unit will also square. So age square, then you have to come back to your original unit. You have to take the square root of the variance, and that is nothing but the standard deviation. And the last measure of the variability is the coefficient of variation. The coefficient of variation indicates the spread of values around the mean by a percentage. So when you have to use the coefficient of variation, for example, if you are having the two different data sets and the units of the measurement is very different. For example, age versus the height. Age, the unit is year, and the height, it may be centimeter or the meter. The units are the different. And if you want to compare the variability between the age versus height, so in that case, the standard deviation or the variance is not appropriate measure of the variation. Here, you have to use the coefficient of variation, which will explain the variation in terms of the percentages. The range is the simplest measure of the variation, but it is very sensitive to the outlier because it's only based on the highest and the lowest observation. When you talk about the interquartile range, if you are having the skewed data or the outlier, in that case, you have to present the result in terms of the IQ or the interquartile range. The variance, the unit are the square of the original unit. The standard deviation is the most commonly used measure of the variation. And the last, coefficient of variation is used to compare the spread between the two different data sets. So this is all about the descriptive statistics, different measures of the central tendency and the measures of the variation. There is one more important thing when you talk about the descriptive statistics, that is nothing but the confidence interval. So when you read any research paper, you always see that the results are always presented in the form of the mean and the confidence interval. So what is mean by this confidence interval? So to really understand what is mean by confidence interval, first you should know about what is mean by the sampling error, and then the confidence interval. So let me explain through this one of the example. Suppose I want to test that whether the average height of a person aged 20 years and above is 160 centimeter or not. So I want to test this hypothesis. So what I will do in a systematic way, from the population, I will take some sample. I will measure the height of each individual from this sample, and then I will calculate the average height. So this sample gives me that the average height is a 159.5. So this is roughly equal to the 160 centimeter. Now based on this sample result, then I'm going to make a conclusion or infer this result to the population that, okay, the average height of the person whose age is more than 20 years in population is 160 centimeter. So, but this conclusion is based only on the one sample or this particular sample. If I consider the multiple sample from the same population, whether my mean will be the same or it will vary. So if I take the three different samples from the same population, so one sample gives me the 159.5, another will give me the 165 centimeter, and third sample will give the average height or the sample mean is a 157 centimeter. So in the mean, there are the some kind of the variation is present. So this is nothing but the sampling error or the variation due to the sampling. So when you repeat the experiment again and again, there is a chances that your result may vary. So there you have to provide some interval. So that is nothing but this 95% confidence interval. So based on the 95% confidence interval, you can claim that if you repeat the experiment and again, what is the chances that your sample mean will range in that particular interval. So therefore, it is always suggested that when you perform a descriptive statistics of your research data, you should not present your result only the single measure of the central tendency or using the mean or average. You have to always provide the 95% confidence interval. It is also gives talk about the variation of your data, because if the 95% confidence interval, the width is larger, it means that in your data there is a large variation is present. So it means that the accuracy or the reliability of the result is very less. And if the variation is very small, it means that the accuracy of your result is very high. So indirectly, it talks about the accuracy of your research finding or the research. Now, once you calculate the descriptive statistics using the measures of the central tendency, 95% confidence interval, uh, or the measures of the variability, then you can use the different graphics to present your data or to convey your messages. Now the next, but this descriptive statistics will help to only describe the data. And the one of the important objective of the conducting the research that you want to make any inference or the conclusion from your research. If you consider an example of the drug trial and you want to show that whether the new intervention is effective as compared to the previous one or the standard therapy, so it means that when you perform a statistical analysis, your research should be able to give that information or you should be able to extract that information. Yeah, this intervention is better. But using the descriptive statistics, it is not possible. You have to use an inferential statistics for that. And when you talk about the inferential statistics, so then you talk about the hypothesis testing. So hypothesis testing, it's a multi-step procedure. So there are the various steps involved in the hypothesis testing, which lead the researcher from making the hypothesis statement based on your research question to the decision regarding to the hypothesis statement, whether your statement is correct or not, whether you have to accept your hypothesis or not. So what are different steps involved in the hypothesis testing? The first important thing is that based on your research question, you have to state the null and alternative hypothesis. So this is the yes no kind of statement only. So my objective is to show that the new drug is effective. So my null hypothesis will be there is a no difference into the standard therapy versus the new therapy, and my alternative hypothesis is that the new intervention is better as compared to the previous one or the standard one. Now the second step is you have to decide the level of significance. So level of significance, this is nothing but your the type 1 error, which is generally considered as a 5%. So in most of the research, they are allowing that the 5% error is okay. Now the third is you have to compute the test statistics from your sample data. So what is the test statistics? So the test statistics is just a one single number which uses all your information or whatever the data you have collected to answer that particular question. Now, again, it is depending upon your the plan method of the statistical analysis. So to answer your research question, you have to use a different statistical test, and the outcome or the result of that statistical test is nothing but this one single number. So once you compute this number, then you have to compare this number with something that is nothing but you have to set the decision criteria, because if this one number is going to decide that whether you are going to accept the hypothesis or reject the hypothesis, then you have to first select the criteria or the set the criteria for the decision, and then based on this you have to make the decision. So this is the traditional way of hypothesis testing. So when there was no statistical software were available, you have to use the statistical table or using the calculator, you have to calculate all the information. But now with the use of advanced statistical methods and the technological development, and there are the various statistical softwares are available. Now this process is very easy. You have to just feed your data into the statistical software. You have to select appropriate statistical test. Then you will get the result in the form of p-value. And you have to only interpret this p-value, and then you will get the result of your the research hypothesis or the research question. And that is also very easy. So what is the p-value? So in simple language, p-value is nothing but the maximum probability of making the type 1 error. So when you set your research hypothesis, that time you have to set your the type 1 error or the alpha, which is generally 5%. So it means that the 5% error you are allowing. So when you calculate the p-value or when you get the p-value, you have to just compare this p-value with the cutoff of the 0.05. If your p-value is less than 0.5, it means that you have accepting your hypothesis. If it is a more than, it means that you have to reject your the research hypothesis. So the rule is very simple. As the p-value smaller and smaller, if it goes towards 0, it means that there is a strong evidences against the H naught or the your null hypothesis. So there is a one decision rule for the p-value. You have to compare your p-value with your the set decision criteria or the type 1 level, that is alpha. Then if p is less than or equal to alpha, then you have to reject your null hypothesis. And if it is a greater, then you have to fail to reject the hypothesis. Conventionally, if your p is less than 0.05, you say that the results are significant. If it is less than 0.01, then it is a highly significant because there is only 1% chance of making an error. And if the p-values is more or less, if 0.001, then your results are extremely significant because there is only 1% chance making error out of 1,000. Now, using the statistical software, it is a very easy to calculate the p-value. But the main important or the main crux is that you have to select the right statistical test. Now there are the n number of the statistical tests are available, and you are having only one research question. It means that you need only one statistical test which will answer your research question. But if there are the so many statistical tests and you have to select that, so it should be correct. Then only your result will be correct. If you made a mistake in selecting the statistical test, then you will get the wrong result. So just to simplify this, how to select an appropriate statistical test, I have simplified this process. So if you just provide the 3 answer correctly to my research question or my question, then maybe I will show you that how to select an appropriate or the correct statistical test for your research question. So first, based on your research question, you have to tell that what is the purpose of conducting this research. Whether you want to find out the difference between the two groups or you want to make any comparison. The second, you want to find out the association between the two variables, or you are interested in finding out the risk factor associated with any particular diseases. The second is what type of your data. I already said that data is one of the important parameter because all your tests are depending upon your type of data. So whether it is a qualitative or the quantitative data. And the third are number of groups. How many groups you are studying? 1, 2, more than 2, and whether these groups are the paired or the unpaired group you are having. So once you provide all this information, then maybe this chart will help to finding out the right statistical test for your research question. So just to illustrate this, suppose I'm having a research question or the hypothesis that a researcher is interested in knowing whether the people with diabetes have the same systolic blood pressure as people without the diabetes. So in this particular research question, sorry. So my purpose is I just want to compare the systolic blood pressure between the two groups. Now you know that the systolic blood pressure, this is a numerical value. So this is a quantitative type of data. And I want to conduct this study into the two groups. So one group is with diabetes and one group is without diabetes. So my purpose is to find out the difference or the comparison. My type of data is the quantitative, and the study is going to conduct it in the two groups. These two groups are unmatched or independent from each other. If you use this table, so you want to find out the difference. Your data type is quantitative. You want to compare the two unpaired groups. So the right test to answer this research question or the research hypothesis is the unpaired t-test. Now another example is a survey was conducted in which a researcher collected data related to the preferred soft drink choice, the Pepsi or the Coke, in 100 males and 100 females. So here you want to find out which is the preferred soft drink choice in male versus the female. So the purpose is again the comparison or difference, but here your data type is the male female, which is your the categorical or nominal data, and the preferred soft drink choice, again Pepsi or Coke. So yes or no, only you are having the two categories. So type of data is the quantitative And again, you are comparing the two unpaired or the unmatched group, male versus the female. Using the same table, the objective is the difference. The qualitative data, you want to compare the two proportions, and the exact test is the chi-square test, using which you can find out whether there is a really difference in the preferred choice of the soft drink between the male and female. Now, just to introduce to some of the most commonly used type statistical tests which we use is the hypothesis testing. So the first important test is the t-test. So when your data is the quantitative or the continuous kind of the data, and you want to compare the average or the mean between the two groups, so at that time you have to use the t-test. Again, in the t-test, there are the different kinds of the t-tests are available. So what are the different types? So first is the one sample t-test. So uh, as the word suggests, one sample. So it means that your study consists only of the one group, and you want to compare this with any hypothetical mean. Just to give an example, suppose you want to compare that the average level of the hemoglobin in a group of the 50 males whose age is 20 years and above is equal to 14 or not. So you have to collect the data of the hemoglobin of 50 males whose age is more than 20 years, and you have to just calculate the average hemoglobin and just need to compare whether it is equal to 14 or not. So here only one group is considered. So it's named as a one sample t-test. Now the second is the independent or the two sample t-test. Now the word independent is clearly tells you that if you are dealing with the two independent group or two unmatched group, and you want to compare the mean for that group, then you have to use the independent sample t-test. For example, the male versus female, a different age group, less than 18 versus the more than 18. If you want to make these kind of the comparison, at that time you have to use the independent sample t-test. And the last is the pair t-test, when you are having the related observation or the sample. So generally the pre-post kind of the data, whenever you want to compare the pre-intervention versus the post-intervention in the same population. So at that time you can use the pair t-test, or the maybe the weight of a person using the two different weighing machine. When there is a some relation present, then you have to use the, or in the related data set, you have to use the pair t-test. The t-test is used only when you are having the one group or two group, dependent or independent or match or unmatched. What if you have the more than two group and you want to compare between the means between the more than two group? Then you can't use the same test. You have to use the ANOVA, that is nothing but the analysis of variance. So when you want to compare the average or the mean between the more than two groups, that time you have to use the ANOVA. So how it works? So it compares the two variation in your data. So one is the within group variation, and the second is the between group variation. So, but when you perform the ANOVA, it gives you the one single p-value. It overall tells you about that whether there is a differences in your the sample or in the three group. But once you find that there is a difference, then you have to find out that in exactly which group there is a difference. It is the first group versus second, first versus third, second versus third, or in which pair there is a difference exists. To find out that, the ANOVA need to always follow with a post hoc test, which gives you that which group differs significantly from each other. So this is all about when your data type is the quantitative or the continuous data, and you want to compare the means or the averages between the two groups. But it is not that you will always get the continuous kind of data. So there are some categorical data is present also. And if you want to find out or make a comparison between these kind of the data set, or you want to find out the association between the categorical variable. For example, I want to find out that is there a more cases of the COPD in the smokers versus in the non-smoker, or whether the males are more prone to the heart attack or the female. So if you want to answer the these kind of the research questions, so I can't use the t-test because here my data type is completely different. It is not a continuous data, it is a categorical data. And if I want to analyze the categorical data, then I have to use the Pearson chi-square or the chi-square test. So this test is used to determine whether there is a significant association present between the two variables. And the results of the chi-square test is always presented in the forms of the odds ratio and the confidence interval. So odds is nothing but the likelihood of occurrence of an event in one group as compared to the other group. So it's nothing but the measure of the association. So if your odds ratio is more than 1, then you can say that in one group there is a chances or the likelihood of happening that event is more uh, as compared to the other group. Or in simple word, there is an increased risk. So this is all about the comparing the two groups versus if you are having the continuous data or the categorical data. But sometimes you have deal with some data. There is some relationship is present. So change in one variable is affecting the result or the outcome of the another variable. So what is mean by that? So when you talk about the age and height, so as your age is increases, your height is also increases till certain age. Or when you talk about the area of house versus the price, so you know that as your area is increases, the price is also increases. So there is a continuous kind of the relationship is present there. So one factor is depending upon the another factor. So if you want to find out that what is the relationship between these kind of the variable, then you can't use the t-test or the chi-square. Then you have to use the correlation and the regression analysis. The method of assessing the association between the two continuous variables is known as the correlation, and the method of the prediction of one variable from the another, it is known as the regression. So when you calculate the correlation coefficient, so the correlation coefficient is always ranges between the -1 to 1. So when you go towards the end or -1 or +1, it indicates that there is either strong negative correlation present or the strong positive correlation is present. If the correlation is 0, it means that there is no relationship between the variables. So it is always suggested that if you get a 0.5 or more number, so the correlation is considered as a significant correlation. Now, this is all about some of the most common statistical tests which use in the different kinds of the research or answering to the research question. Now, just to take a hands-on about the real life data, I'm having the data of the volume of the tumor in centimeter cube of the 100 patients. So, aged 30 to 60-year-old was collected. Now, the data was collected by the two physicians. They have measured the tumor value. And along with this, they have collected some other information like the age, gender, and these are the age group. So the age they have converted into the different age group, 30 to 40, 40 to 50, and 50 to 60. Now, once you will get the research data or any data, you can ask n number of the research questions. So it is always important that you have to ask the maximum number of the research question to your data. Then only you will be able to extract the more and more information from your data. So based on this data, so I have formulated the few research questions. So my first research question is, did the measurement from the two different physicians, Dr. 1 and Dr. 2, it significantly differ for the volume of the tumor. Now only the tumor size for the same patient, but only the measured by the two different physicians. So if I want to answer this particular research question, then I have to use the pair t-test. Now the second research question may be, does the average tumor volume between the males and females differ significantly? So the male versus female, two different groups which are not correlating with each other. It means that I have to use the independent sample t-test. The third question may be, is there any relationship between the age and tumor volume? So it means that as your age increases, is your tumor, is the size of the tumor or the volume is increasing or decreasing? If you want to get an answer for this question, you need to apply the correlation analysis. And is there any association between the age group and gender? Whether it is equally distributed across the different age groups. So if I have to answer this question, then I have to use the Pearson chi-square test. Now, to perform a statistical analysis, generally you need a statistical software, then only it will be easier. But using the Excel also, you can perform the simple basic statistics. And nowadays, there in the YouTube also, there are the videos are available, which can be help us to use or analyze this data. So just to demonstrate this, so I'm going to show you that how you can perform the pair t-test or the independent sample t-test using an Excel. The same data I have taken into the Excel. So this Excel spreadsheet, I'm having the information about the gender, the different age group, age, tumor volume, and tumor pool. And I copied the same research question. Now, my first research question is that I just want to compare that whether the tumor volume measured by the two different physicians are same or not. So I have to use the pair t-test. So what you have to do? So the first thing is that you have to go to this function. So once you go to the function, then there are the different option will come. So from this function, you have to select the just the t-test. So here you need to feed in information. Information is nothing but the data. So in the first array, you have to give the data of the tumor volume measured by the first doctor. In the second array, you have to give the data of the tumor volume measured by the second doctor. Tests, these are the generally two-tailed statistical tests are using, and type. So here they will give you all the information. So type is the kind of t-test. If you want to perform a pair t-test, you have to enter 1. If you want to do independent sample size with equal variance, then you have to enter 2 and otherwise 3. Now we want to perform a pair sample t-test. So that's why I have entered 1. So if you give all this important credential or the information, so just click on the OK. So this gives you the value. So what is this? So this gives me the 0.458. So this is nothing but the p-value. Now you have to compare this p-value with the 0.5, that is your cutoff. Now since this p-value is more than 0.05, it means that the tumor volume measured by the two different physicians. So there is no difference. Now the second is, my second research question was that, does the average tumor volume between the males and females differ significantly? So here the male versus female I have to compare. So I have to use the independent sample t-test. Again, for the independent sample t-test, again I have to go to the same, the function, then you have to select the t-test. But here in the first array, you have to select the data of the male. Now the gender I have coded into the two. So one is a male and the second is the female. So in the first array, I have to take only the male data. So the male and female data, I have colored with the different color. So it will be very easy to differentiate. So this is first, I have to select the male data. And in the second array, I have to select the female data. And again, it is a two-tail. And since I want to perform the independent sample t-test, so I have to enter the type as a 2. So now this will give me the value of p-value is 0.6957. So again, this is a more than 0.05. It means that gender-wise, there is no difference into the tumor volume. So similarly, my third research question was, is there any relationship between the age and the tumor volume? So I need to find out the correlation between these two. So to find out the correlation, you have to go to the function and then you have to select the function as a Pearson. In the array 1, you have to provide the information about the first variable, that is the age. And in the second array, You want to find out the relationship with the tumor volume. So this gives me that the correlation coefficient is 0.02. It means that it is a very small. So there is a very the small or the correlation between the age and the tumor volume is not very significant, you can say. You can also draw a simple scatter plot also if you just want to find out the correlation. You have to just select these two data, go to the insert, charts, and select the scatter plot. So this will give you the scatter plot. Okay. In the scatter plot also, if you just add the trend line, so using the graphic also, then you can interpret that whether there is a correlation is present between the two data or not. So since the data is scattered all over across, so it clearly tells you that there is no significant correlation is present between the age versus the tumor volume. So using the Excel also, you can perform the descriptive statistics, also some of the basic inferential statistics. And as a student, it is very important because the Excel is freely available and you can use. If you talk about the statistical software, all the software are the paid software. So that is, as a students, I will suggest that you can use the Excel for the graphics and all the basic analysis. Now this is the same procedure, whatever we have performed currently, the t-test using the Excel. Now if you perform the similar test using the SPSS or the other software, then you will get these kind of the output. So the first we have performed the paired sample statistics. So in the first table, they gives you all about the descriptive information. So the tumor volume measured by the first physician, that is a 20.6 versus the tumor volume by the second, it is a 20.26. So from the just by observing the mean, you can say that there might be no difference between the measurement by the two different physicians, and the p-value also tells you about the same thing. So from this, you can conclude that there is no statistically significant difference in the tumor volume measured by the two different physicians. So similarly, I have applied the statistics for the independent sample t-test, and you get again the same result. So significant t-test is nothing but the p-value, and based on this, you can conclude that there is no significant difference in the average volume of the tumor between the males and female. So the correlation also, so SPSS output gives you the exactly the same value, that is your coefficient is 0.021. So it indicates that there is no significant correlation between the age versus the tumor size. So this is all about the descriptive statistics or the basic statistical test which is used in any research or hypothesis testing, and just I have given the hands-on using the some of the Excel. Now the few carry home messages for this. So when you want to conduct a research, so framing a good research question, it forms the foundation for getting the good, systematic, and organized statistical meaning to the data in hand. The project planning, execution, and reporting are the three key pillars to good research work. Knowledge of statistics help to simplify the huge data set and also help you to present the fact in precise and the definite form. Statistical merely include the collection, organization, analysis, interpretation, and presentation of all the information which is collected by the researcher. Sample size calculation is one of the most essential component in conducting any research, and it should be calculated taking into the consideration that it should be the scientifically, ethically, and economically also feasible. An appropriate statistical test is selected based on the purpose of the study, what type of the data, and the total number of the variable in the groups. And selection of appropriate statistical tests is very important. Otherwise, it misleads your all research finding. And lastly, the statistical output help to make a reliable and objective decision, which in turn support making the suitable policy. So with this, I would like to end my presentation. Yeah, thank you.
Yeah, thank you so much, madam, for the wonderful presentation. Like, we really enjoyed it. Uh, yeah, coming to the doubts, there is no questions by the
Okay.
audience.
Okay.
So, any specific other than related to subject, would you like to tell any advice to the young budding researchers related to statistics?
Okay, so one thing I definitely would like to say that so most of the researcher or the doctor always feel that the statistics is very difficult or the statistics is not their cup of tea, but it's not like that. If you understood that the statistics, if you correlate with your research question or with your data, or if you try to understand that what is the how the statistician perform the analysis, that it is actually you can generate the more important or the extract information from your data. If you just give the data to a statistician and ask them to analyze, then for the statistician, these are the just the number. They can use the different statistical tests. So based on the statistical assumption. But as a researcher, you know the importance of your data, what this information is really meaning. So I always suggest that you have to sit with the statistician, explain him the importance of each and every parameter. Then only definitely you will get a good result or you can make the inference of your the data. That's the only thing.
Mm, yes, madam. Like one more thing is, like if we see the output of the results, mm,
Yeah.
most of the like, is it always like hypothesis and conclusion? Like sometimes the expected results may not, the expected results are may not be as expected.
Hello.
Hello. Yeah,
Yeah.
internet connection was bad, madam. Like the expected outcome, like suppose if we start a research paper, we may assume like these response should be like this, but at the end of the
Yeah.
statistics, it may not be like that. Like how it affect the manuscript, like what are the journal point of view on these type of results, like evidence based results in the sense.
Good research, but whatever the finding or the how the data will come, it is not in your hand actually. So whatever is come is the real life situation. So if you get the negative result or you are not getting the result as you are expected, in fact, it always give a larger scope to analyze your data in more depth, and you find out the answer, and it will give you a chance to find out the answer that why you are not getting the result. And this I would say that this also can help us to lead or the design the future research also. So the negative finding is not that sometimes it is a very good I can say, because it set the foundation for the next research also.
Yeah, thank you, madam. Ashwini, you can continue for vote of the.
Thank you so much, ma'am, for the wonderful session. It has been very informative. I know most of the young research minds in the session got to know the importance of biostatistics and its application. And I'm also sure that they're going to apply it soon. So thank you so much, ma'am, for taking your time out and doing the session with us.
Thank you.
Yeah, can you please stay here for a few more minutes? I will end the live stream in YouTube.